So we are going to start with HDFS and HDFS architecture. Now we are starting with this, and HDFS is having various components. First component is the name node, data node, and then handling the failures. This is also the part of HDFS architecture. The basic components are name node, data node, and then client environment. We have to discuss about the client environment for the HDFS, and write operation, how the write operation will be performed, and read operation, how the read operation will be performed, and then rack awareness, what is the rack, what is the importance of rack, and how can we maintain the racks, that we will discuss in this session. Now, as we discussed, HDFS cluster. Cluster means it is a collection of resources. Here the resources are the servers. Please don't think that this is the server and all these are the clients. No, there is no client server architecture. All these are servers only. Okay. Now, as we discussed, if we have a file to store, then this file will be divided into blocks. This file should be divided into blocks. Now, in the blocks, block 1, block 2, block 3, in that the block 1 can be stored in the first mission, the block 2 can be stored in the next mission, the block 3 can be stored in another missions, and some other blocks will be stored in different missions. So here generally the block size will be 64 MB in the standard format of old versions of the Hadoop. But the latest versions, that is from the Hadoop 2.x onwards, the block size was changed to 128 MB instead of 64 MB. So each block will be 128 MB, and that will be divided, the file will be divided into 128 MB, and the number of blocks will be stored over the machines and a cluster. Now in this, now we have the file 1, block 1, block 2, block 3, and so on. This is okay. Now I have file 2. The file 2 will be also divided into block 1, block 2, block 3. Now if you want to get the data from file 1, who will tell that this block related to file 1, this block related to file 2, who will tell that? That is by using, we have to maintain the mapping method, meaning that this file is having these many number of blocks and these blocks are available in these meshes. We have to provide the mapping table. That mapping table has to be maintained and that will be maintained on the another mission. So see here, this is, so this is the file 1, block 1, it is available in node 1 and 3. Why it is node 1 and 3? Because see here, block 1 is available here, for the file 1, block 1 is available here. Let us say for example, if we lost this particular mission, this mission is failed. In that situation, where can we get the block 1? So because of that reason, we have to maintain the replication of the block 1. So for any block, it will maintain multiple copies of that block. That is called the replication. It is not the duplication. Replication is different, duplication is different. Duplication means another copy. Replication means exact whatever is there here, the exact thing will be available other side also. The duplicate means if you change here, you have to change other copies separately. But here replicate means whatever is here in this block, the same should be reflected on the other side also. That is replication. So see here, you can understand that here block 1 is stored 2 times. This is related to file 1. Now where the blocks are available for the file 1, block 1, in the node 1 and node 3. 1, 2, 3. So here file 1, block 1, it is available in node 1 and 3. And file 1, block 2, it is available in block 2 here, 2 and 5. We can say that 1, 2, 3, 4, 5. Of course, that the nodes will be also identified with some number, that is identifier will be available, that we will discuss later. So see here, the file 1, block 2 is available in these missions, and file 1, block 3 is available in several missions, and file 2, block 1, it is available in another missions. Like this, we will maintain a table. Here this table is maintaining the names and namespace. We can call this as the namespace. and this namespace can be stored in one mission. So we have to maintain this also in one mission. We will dedicate one mission to store this namespace only. So because of that reason, all other missions, they have to communicate with this mission for the reference and for the mapping. And also, since the namespace is storing in this mission is called the NameNode, meaning that the actual data is not available here. Only the metadata. The metadata will be available here. File 1, block 1. It is available in different missions like that. And actual data, where the actual data is stored? It is in the form of the blocks. All the other missions are stored in, all the other missions are having the actual data in the form of the blocks. So because of that reason, they are called the data nodes, name node and data nodes. So now we have to discuss about what is the name node in detail and what are the data nodes in detail. Now in this case, we have to discuss about the name node. Let us start with the name node. Now the name node is also a mission. All the missions are having its own environment, operating system, local file system and the local RAM. All these are available. Now in this, here the name node is having the RAM and also it is having the local file system. In this, whatever we have seen, that namespace, that namespace will be stored in the RAM. Entire namespace will be maintained in the RAM only, in the name node. So the namespace is again how it is maintaining the namespace, that is in the form of the image. So this is the image. Okay, now again in the image and also list of blocks separately. Again inside the image, the entire namespace is in the form of the image and the blocks, and inside the image how it is maintaining the files. The files will be maintained in the form of the inodes. Now the inode consists of the permissions, modification, access time, namespace, quota. All these are available in the inode. Inode will be available for each and every entry of the HDFS, that may be the file or directory. Now here, and another thing, in the namespace, list of blocks, you can observe that the list of blocks are separate. It is not the part of the image. And now how can we start this name node? Whenever you start the name node, what will be happen? Before discussing about that, what it is maintaining on the local file system of name node. In the local file system, it will maintain the checkpoint. What is the checkpoint? That is the persistent state of the image. Here, this is the RAM. Whenever you switch off the mission, the RAM will be cleared. You will not have anything. So because of that reason, we have to maintain this image in the persistent state, in the permanent storage. So the image can be stored in the form of the checkpoint in the persistent state in the local file system of the name node. And along with this checkpoint, it will maintain the journal also. Journal means it is the transactions or modifications. Let us say, for example, if you insert some file, if you upload some file, the transaction will be maintained, that transaction will be created. If you delete a file, another transaction will be added. So like this, each and every transaction will be recorded in the journal. Now let us go with the starting of the name node. How can we start the name node? What are the steps in starting of the name node? There are 5 major steps in starting of the name node. First step is, initially whenever you start the name node, RAM is free, RAM is empty. Now whenever you start the name node, immediately the checkpoint will be loaded as the image into the namespace area, and the second point is the journal will be loaded and this will be replayed. It will be replayed in the image so that the image will be up to date. And the third step, it will create the image, it will update the image at the checkpoint, meaning that the checkpoint will be overwritten by the image so that the checkpoint is up to date. In the next step, the journal will be empty. Empty the journal. Because the journal is updated in the checkpoint at this stage, so the journal will be empty and then it can start service. So these are the 5 major steps to start the NameNode. Now I think you may not be able to understand it in one go. Now I am going to explain in different way. Now initially, in the first stage, I am going at the first stage. In the first stage, the RAM is having empty. So initially the RAM is empty, meaning that the namespace is empty, nothing is there. Now whenever you start the mission, whenever you start the mission, the checkpoint will be loaded. First step is load the checkpoint. Initially the checkpoint is also empty, nothing is there. Now in this step, first step is it will load, the checkpoint will be loaded into the image. Now in this case, empty image is created, empty checkpoint is loaded. Next step is load the journal. It will take the journal, it will replay. Initially journal is also empty because it is let us say that it is the new cluster. In the new cluster, checkpoint is empty, journal is also empty. So in this case, here we are loading the data into, we are loading the journal entries into the image and it will be replayed, all the transactions will be replayed and it will be updated here. So nothing to update because checkpoint is empty, journal is also empty. So nothing to update. So the empty checkpoint, the next step is the empty image that will replace the checkpoint so that again it is empty. So empty will be loaded. Now at this time the journal will be empty, already it is empty, now again it will be empty. Next step is the cluster is ready for service. Now at this stage I am uploading one file. Now the file will be updated here and an inode will be created and that will be recorded in the journal. File 1. Journal will be updated, not the checkpoint. And then I uploaded another file. That will be also updated in the journal. Now at this stage, if you shut down the machine and again restart it, at this stage, now what will be happen? Again, in the first stage, the RAM is empty. Now the checkpoint is loaded. Checkpoint is empty. You can observe that. And journal. What about the journal? Journal is having 2 entries. File 1, file 2. So these file 1, file 2 will be updated in the image. And now this updated data will be uploaded as the checkpoint, that is file 1 and file 2. These 2 are updated at this moment. And then journal becomes empty, so empty journal will be there. Now the checkpoint is updated and in the next stage again it will be ready for processing and ready for service. Again if you want to upload one more file, then another 2 files I am uploading. These 2 files are updated in the image and this will be available in F3 and F4 in the journal. Okay, now again if you restart the machine, at that time these 2 files will be now at this stage F1, F2 are loaded and then journal, from journal F3, F4 are loading and they will be replayed and they will be updated in the checkpoint F3, F4. Now this is the concept of the NameNode starting. We can continue in the next session.